It is known that when current passes through a conductor, some part of the current is converted into heat. The heat so produced is directly proportional to the square of current, the resistance, and the time for which the current flows. The generation of heat is an inevitable consequence of current. This heat is generally undesirable, but in certain devices like electric heater, electric oven, geysers, electric iron, etc., heat is a desired form of energy. That is, most of the electrical energy needs to be converted into heat energy. Such devices generally use metals or alloys that offers high resistance. For example, like nichrome. One of the devices that works on the heating effect of current is the electric bulb. A bulb has a filament made of tungsten which offers a high resistance. Tungsten also has a very high melting point of the order of 3380 degrees Celsius, and so when it becomes very hot it starts emitting light. We also say that tungsten becomes incandescent, that is glows at very high temperature. The filament should be thermally isolated as much as possible by using an insulating support. The bulbs are usually filled with chemically inactive gases like nitrogen or argon. If the filament by chance comes in contact with air, it can get oxidized. So the gases are filled in to prolong the life of filament. In a bulb, most of the electrical energy is converted into heat energy and only a small amount of it gets converted into light. Fuse is another device which makes use of the heating effect of current. It is a safety device which is connected in series in a circuit and protects the circuit and the appliances by stopping the flow of a very high amount of current. It consists of a thin wire made of an alloy or a metal of generally low melting point. The fuse wire is encased in a cartridge of porcelain or similar materials having metallic ends. Every fuse has a rating. For example, like the fuses used for domestic purposes are rated as 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere, etc. That is, this is the maximum permissible current which can flow through the fuse wire. If a current larger than the specified value flows through the fuse wire, then it becomes very hot and finally melts, thereby breaking the circuit. Thus, the fuse protects the appliances or the devices from getting damaged. So, fuse also is a device which is based on the Joule's heating of electric current. Now, let us consider an example related to fuse. Let us consider an electric iron which consumes 1 kilowatt electric power operated at 220 volt. We will see that the current flowing through it will be 4.54 ampere. How do we find the current flowing through the circuit? The current can be found by using the formula of power where P is equal to V into I, where V stands for voltage and I stands for current. In the above situation, the power is given as 1 kilowatt which is equal to 1000 watt and the potential difference is given as 220 volt. So we know that I is equal to P upon V, which is 1000 by 220, which comes out as 4.54 ampere. Therefore, in the above case, the most feasible fuse that can be used is a rating of 5 ampere. These are the two major examples of electric bulb and fuse which is based on the heating effect of electric current.